All right, so today we're going to focus in more on each parent function and how they move. So we talked about this obviously a lot last week. Um, Individually, we focused in, is it moving left or right? Is it moving up or down? Is it stretching or shrinking, etc. So today we're going to kind of put it all together, and we're going to focus on what we call translation of a function. Okay, so your translation is exactly what we did last week. We are moving it vertically, horizontally, or both, but not changing its shape. So at first, we're just going to focus on the horizontal and vertical movements, and then we'll kind of get into some other stuff as well. But if you look, I filled these in for you, so hopefully you can as well. Each of the points, it says plot as many points as fit on the graph, so that's going to ring true for the first three. Obviously, when we get to absolute value, I'd like to see at least 5 to 7 points to get a nice graph. If you want to do all the points, you can. You will see me do that sometimes. It just kind of depends on what you're comfortable with. If you feel like you can draw pretty straight lines without it, then please do. You can see that my right side is pretty straight on here, but the left side kind of went haywire. So just try and get them as straight as possible. And then we want to just remember our patterns, right? In this case, you're always going from your critical point, which is at 0, 0, and you're going right 1. And then in this case, you're squaring it, right 2 squaring it, right 3 squaring it. Whereas over here, your parent function is the square root of x. So when you go right 1, now you're square rooting it. That's why we went right 4, because 2 and 3 are ugly when you square root them. So 1, 4, 9 here. Same thing here. This is the cubed root of x, so the cubed root of 1 is 1, but then the next pretty cubed root is 8, which is why that pattern looks the way it does. And then absolute value is nice and pretty. That's kind of what's creating almost like a slope of a line. You have opposite slopes there, right? Up 1 over 1, up 1 over 1, up 1 over 1, because the absolute value of 1 is 1, the absolute value of 2 is 2, the absolute value of 3 is 3, and so on. So if you look at this table, it says fill in the table for each translation. So you guys, we want to remember that everything is based off of y equals a times x minus h plus k. Now, notice I don't have anything in there in terms of a squared, in terms of a square root, in terms of a cubed root or absolute value. Remember, the parentheses are taking the place of whatever your parent function is. So what I mean by that is, okay, if we're going up 7 units here, up is a k value. So that means here, the only thing I'm going to have is k. So this would be m of x equals x squared plus 7. Okay, if that's the only thing that's happening, then you have that plus 7. Okay, so the only thing that changes going across the board is the parent function. A of x, if I want to move it up 7 units, well, it's starting as the square root of x graph, but I want it up 7 units, so I'm going to add 7 on the outside as a k value. Same thing with t of x. I have t of x equals the cubed root of x, and then plus 7, and h of x equals the absolute value of x plus 7. Okay, so the only thing that's changing there is the parent function. You're doing the exact same translation every single time. They're all being moved up 7. Now, if you look at the next line, this is not giving you the actual description. It's just giving you the function. So this is inside your parentheses here. So inside your square root or inside your cubed root or inside your absolute value. It's all the same thing. This means I'm doing a horizontal movement, and we're doing opposite. So it's plus 8, which means we're really going to the left 8. So then all of these, m of x, because it's horizontal, we want it inside the parentheses. So x plus 8 squared. And then we want t of x to be the cubed root of x plus 8, and h of x to be the absolute value of x plus 8. Okay, so it might help you to pause the video and give the rest of them a try. So the description, then write them in, and then I will go over each of them as well. All right, so hopefully you've given yourself some time to look through these. For this one, we have a horizontal shift to the right 2, and we have a vertical shift up 5. So we are going right 2, because we're doing the opposite, and up 5. So if I want an x squared graph to go right 2 and up 5, then I'm going to have x minus 2, because it's the opposite, squared plus 5. So you guys, they look the exact same. You're just changing the parent function. That's what we want to stress here. So a of x would then be the square root of x minus 2. Make sure that it's very clear that that is under the radical. And then you have a plus 5, okay? You guys, that's important because some people get sloppy with their radicals, and if I cannot determine whether it's inside the radical or outside the radical, I cannot assume that you knew what you were doing, so make it very obvious that it's underneath the radical. Here for t of x, you would have the cubed root of x minus 2. Again, I'm going to extend that radical because I'm not sure. Plus 5. The other thing, you guys, don't forget that cubed root. If you mean a cubed root, I need to see the 3 there. Okay. Down here, we have left 6 units and down 10 units. So for m of x, if I'm going left 6 units, that's going to be x plus 6 squared down 10 units is a minus 10. And then hopefully these all look the exact same, except your parent function is different. So the square root of x plus 6 minus 10. And then again, the cubed root of x plus 6 minus 10. And h of x would be the absolute value of x minus, nope, just kidding, x plus 6 minus 10. So I was a little ahead of myself with the minus. Okay, so all of those are saying we're going left 6 units and down 10 units. And then according to the parent function, once you had your critical point, so your critical point is going to be the exact same no matter what parent function you're dealing with. It's really then launching into the next points. That's what's going to determine your graph. Okay. For the last one, we have right 1 unit and down 3 units. So m of x, if I want to go right 1 unit, that's the opposite. So x minus 1 squared, and then down 3 units would be a minus 3. And then that same pattern will follow the square root of x minus 1 and then minus 3. T of x will be the cubed root of x minus 1 minus 3. And h of x will be the absolute value of x minus 1 minus 3. So that's focusing on the left, right, up, down. Okay, we can't forget our a value as well, though. So now we're going to talk about that, and we're going to actually write the equations of graphs below. So the first thing I always figure out is my parent function, then my critical point, and then my a value. Okay, so remember those are the 3 things you want to pay attention to. What is your parent function? And then what is your critical point? And then what is my a value? So those are the 3 things that are going to help me determine writing the graph. So I would look at the very first one and see, okay, clearly it's a square root graph, right? It's that half a parabola. So I'm going to have the square root of something in there. Okay. So if I'm looking at this, I have 2 things here. My critical point is right here at the point 1, 2, 3, 1, 2, 3, 4. Okay, so that is going to be my h and my k. So I know that I'm going to have x minus 3, because I'm going to the right 3, plus 4. Okay, so that'll get me the correct critical point that I want. Now you need to look at that a value. So here, your a value, you know how in all of these, I'm going to scroll back up to our warm-up. If you notice, no matter what, from your critical point, you went right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1. that is your A value, the up part of it. So I'm going to look at this and say, okay, if I go right 1, to get to that point, I had to go up 2. So this distance is my A value, which is 2. Because normally if I go right 1, up 1, well, I doubled it clearly, so A is 2. So that means down here, I need a 2. Then if you look, this is a square root graph. Normally you would go 1, 2, 3, 4 to the right and 2 up. And now you're going 4 to the right and 4 up. So again, you're doubling. So you can double check it. But it will always, always, always be, if you go right 1, the distance you need to get to the graph from there is your A value. Okay. All right. If you look at number 2, we have an absolute value graph. So I'm going to have some form of absolute value. My critical point here is the point -2, -1. So I'm going to have x plus 2 minus 1. So then that means I'm moving left 2, down 1. That's good. My A value, if I go to the right 1, typically I'm going up 1, but now I'm actually going down 1. So that tells me that A is a -1. So you can write -1 or just negative out here. Okay. And then over here, my parent function is a cubed root graph. It's the snake. Don't forget the 3 in there. Okay, your critical point here is the point -3, 0. So that means I have x plus 3, but then I don't have a k value, so I don't need it. My A, if I go right 1, up 1, I'm right there. So that means A is 1. So I don't need anything. So that is your whole graph, right? You would have a 1 there, but we don't write it. Cubed root of x plus 3 plus 0. So that's your graph. Okay, so that A value is always right 1, and then however far up or down you need to get to the graph from the right 1 is your A value. All right, so now this is just a different way of looking at it, rewriting the functions given the transformation. So we have a bunch of different functions up here, and we have a bunch of different transformations, going on. So if you look at number 1, it says e of x plus 3. So that means I'm going to take my function e of x and add 3 to it. So I want to move it up 3 additional units from where it is. Well, if you look at e of x is always already moving up 11. So if I want to move up 3 more, then I had to have -x plus 14. Sorry, I forgot that e of x part. That's kind of important to make it a function. Okay, now over here, I want to go from wherever my function of p of x is, I'm going to go right 2 units, and I'm going to go down 9. Okay, so if you look at number 2, let's see, we have p of x, so that's this one. Okay, well, your critical point right now is the point -9, -3. I want to go right 2 units from that. So if I'm at -9 and I want to go right 2 units, then I'm really going to be at -7. So p of x would be the cubed root of x plus 7. And then I want to go down another 9. So I'm at -3, down another 9 would be -12. So essentially, mathematically, it's working out, right? I'm subtracting 2 from the inside. I'm subtracting 9 from the outside. Over here, I'm going to the right 3 and up 4, and then my A value is doubling, so whatever it is needs to double. So S of x is right here. Okay, so let's start with my A value. If my A value is 1/2 and I double it, 2 times 1/2 is just 1. So S of x will now have just an A value of 1. Okay, my critical point is at the point -1, -7. Well, I'm going to move it right 3, which means it is now at a +2, so x minus 2, right? We want to do the opposite. And 1, essentially -3, is -2. And my critical point is at -7. I want to move it up 4, so -3. Okay. Number 4, let's see, we have, we're moving down 5 and we need to multiply our a by -1. So a of x is now, let's see, okay, so my a value in a of x was -3. I'm going to multiply that by -1. It's now a +3. That x plus 5 isn't changing inside the absolute value because I'm not doing anything to my horizontal shift, but my critical point that was down 10 is down another 5, so -15, right? -10 minus 5 is -15. For number 5, excuse me, I am going to the left, sorry, I almost wrote it right, left 6 and down 1. My a value needs to get multiplied by 1/4. So for c of x, if I multiply my a value, which is 2, by 1/4, now I'm at 1/2. 2 times 1/4 is 1/2. My critical point was at 4, 6. So if I'm at 4 and I go left 6, I am now at x minus 2. Nope, sorry, plus 2. Right? I was at 4, yep, and I'm going left 6. There we go. We want the opposite. Don't forget to square it because that's your parent function. My critical point was at 6. I'm moving it down 1, so plus 5. So you guys, the easy way to check that is I am at -4. -4 plus 6 is +2. I was at 6. 6 minus 1 is 5. Okay, so mathematically it works out in the wash as well. And then last but not least, r of x, we are moving to the left 3 and up 2. So our new r of x function, the 4 isn't changing. My a value wasn't messed with. But I was at the point 5, -2 for a critical point. So I went left 3 and I went down 2. So that means if I'm going left 3, I'm going to end up, this is a cubed root graph, at x minus 2, right? Because I was at 5. I want to go left 3, so really be at 2. And then I want to go up 2. Well, -2 plus 2 is 0, so you don't need to write the plus 0 in there. Okay, so again, it works out. -5 plus 3 is -2. -2 plus 2 is 2 or 0, so there's nothing there. Okay. All right. Last but not least, we're going to do this transformations idea with some word problems, which aren't as difficult as they seem. The revenue function for a model helicopter company is modeled by the curve f of x equals -5x squared plus 400x. Where x is the number of helicopters built per month and f of x is the revenue. Okay, you guys, as always, this is really important. X is the number of helicopters built per month and f of x is the revenue. So that's your y, right? The owner wants to include rent in the revenue equation to determine the company's profit per month. The company pays $2,250 per month to rent its warehouse. In terms of f of x, what equation now describes the company's profit per month? Compare the vertices of the original function and the transform function. All right, so here, if you think about it graphically, this is our number of helicopters. And this is our revenue per month. So revenue is how much money, right? Revenue equals profit minus cost. So it's how much money you're left over with. So if this owner is going to pay $2,250 per month, then his revenue has to go down if he wants to include that. Okay, so his revenue will show a loss of $2,250 per month because that's money that would be going out of his pocket. So if you think about this, I'm going to go into more probably detail than we really need to, but I want to make sure you understand what's going on. Let's take our original function and let's find the vertex. So x equals, the opposite of b is -400 all over 2 times a, which is -5. So we end up with -400 all over -10. So 40. Okay. Our y value is then negative 5 times 40 squared plus 400 times 40. So if we put that into our calculators, you should end up with negative 8,000 plus 16,000. So you end up with a positive 8,000. Okay. So that means that I have a vertex of 48,000. Okay. So I do have a y-intercept of 0 here. All right, so this is our graph. And we know that this is the point 48,000. So this is saying right now that when 40 helicopters are built per month, the revenue is $8,000. However, he wants to take that and he wants to apply the fact that actually I'm not making $8,000. I need to bring that revenue down. I'm still making 40 helicopters a month. However, that revenue equation wasn't taking into account my rent. So if I take away my rent from that $8,000, I'm going to subtract 2,250 from 8,000, and I will end up with 5,750. Okay, well, in doing that, that's going to change a couple things. Okay, so that's a vertical change, so that's our K value. So if you think about it, we started with f of x equals negative 5x squared plus 400x. A vertical change is a plus or minus k. Well, that's at the end here. So even though this is in standard form, adding or subtracting something to the end doesn't do anything, right? Essentially, all I'm doing is taking my whole function and subtracting 2,250 from it. But what you do to one side, you have to do to the other, right? So our new revenue function would be f of x equals negative 5x squared plus 400x minus 2,250. And that would be your new function. Okay? All right. All right, number 8, Miss Fitzharris and Mr. Q went golfing. Mr. Q went first. Oh, we're going a little crazy. He's clearly not a gentleman. His ball landed 18 yards short of the hole and followed the path modeled by the equation Q of x equals, and that's in standard form. Miss Fitzharris teed off 18 yards closer to the hole because she is using the same club, and clearly I have the same muscles that Mr. Quatman has. She realized that if she could hit the ball in the same trajectory as Mr. Q, her ball would land right by the hole. What is the equation that describes the path that her ball should follow? All right, so let's think about this. We're golfing, right? So we're going to have height of the ball. Let's see. Oh, sorry. This is yards to the hole. Okay. And then it doesn't really say anything about what the y value is in this problem, mainly because we don't really need to know what it is. But let's just say it's height of the ball, just to give it something. Okay. Now, again, I know, given this, that my y-intercept is 0, right? It's in standard form. I don't have a c value. So obviously we're starting here and the ball is going and then landing. Okay. Now that is the red is the flight of Quatman's ball. Okay. Now this is saying his ball landed 18 yards short of the hole. So that means that's where his ball went. But the hole, let's say, is right here. And this is a difference of 18 yards. And I want to get a hole in 1. So I'm going to use that exact same trajectory, but if I'm not doing anything else to this, and I am going to hit it the exact same way, that means this is happening the same way. I'm just going to There we go, clone it. I'm going to make it a different color so we can kind of see the difference here. I'm going to say, okay, I can do this exact same thing. However, I want a hole in one, so I need to move 18 yards closer to the hole. So what that means, think about the movement that just happened there. That is a horizontal movement of 18 yards. Okay, so if I'm taking this equation right here and moving it 18 yards to the right, technically instead of q of x, I have q of x minus 18, right? Because if it's inside the parentheses, it's a horizontal movement, and we do the opposite. Well, that means that I'm going to take this, and I need to replace all of my x's with x minus 18 in order to have an equivalent function. Okay. Now, in the last problem, we just added it to the end. Well, we could because that was vertical. It was easy. Vertical, you just add to the end. However, horizontal, you're changing the x. Well, in this case, I have two x's, so I need to make both of these represent the fact that I'm moving it 18 yards to the right. Okay. Just for good practice, let's go through and actually get what that would be. So we have negative 0.0009. Remember, that is x minus 18 times x minus 18 plus 0.2088 times x minus 18, which I'll hold on to for a second. So we end up with negative 0.0009. If we multiply that out, we get x squared. Negative 18 times negative 18 plus negative 18 is negative 36x. And 18 times 18 is 324. Plus, we'll just do all of our distributing at one point. You guys, the numbers are ugly here. The process is not difficult. Okay. So now I need to distribute this in. And I need to distribute this in. And then I'll clean it all up. Okay. So negative 0.0009x squared. If I have, hold on, I'm going to get my real calculator out. I've been using my phone, which I don't know how you guys do that. That drives me crazy. Negative 0.0009 times 36. I end up with a positive 0.0324x. And 324 times 0.0009, I get a negative 0.2916 here. So that's what I get when I multiply through the orange. Then I'll have 0.2088x here. 0.2088 times 18 gives me minus 3.7584. Awesome. All right, let's quick combine like terms. This guy is on his own. This x and this x go together, and then these two go together. So I end up with negative 0.0009 x squared. If I combine my like terms, 0.0324 plus 0.2088 is a positive 0.2412x, and negative 0.2916 minus 3.7584 gets me a negative 4.05. So that's the path that I need to take in order to, we'll call this f of x for Fitzharris, in order to get a hole in one in standard form. Okay, which all started from changing all of my x's to x minus 18s because I knew I needed to move 18 yards closer to the hole. So graphically, that was a movement of 18 to the right. Everything from there was just being really careful. You guys did that last unit, and just being really careful with your decimals. Okay. All right, as always, let me know if you have questions.